All right, here we go with the 2024 free response question on BC Calculus exam is question number 5, calculator inactive, and this is a BC only question. This one's a strange one in that there's not really a kind of an overarching theme for the whole thing. They're just putting some bits and pieces together of different BC Calculus kind of things. You'll see that. When we take a look at the question, the function f is twice differentiable for all x, and it gives us some initial condition here. F of 0 is equal to 0, probably going to be important. Values of f prime, the derivative of f, are given in the table for selected values of x. For part A, for x greater than or equal to 0, the function h is defined by h of x is equal to definite integral from 0 to x square root of 1 plus, this looks familiar, f prime of t squared dt. For value, find the value of h prime of pi and show the work that leads to your answer. So this obviously, in case it's not obvious, is arc length. Not that it's asking us what the answer means, but that's essentially what it is. Okay, so if we are finding the derivative of an integral equation, that to me sounds like one of the fundamental theorems of calculus, which looks like this. Just generally speaking, taking the derivative with respect to x of, bracket, the definite integral from some value, and for us it's, I think, 0, to x of f of t dt, that is equal to f of x. In other words, this is the version of the fundamental theorem of calculus which establishes the inverse relationship between this antiderivative action, these definite integrals, and the derivative. Okay, so I'm just applying that right here. I actually don't need all of that much space here. For answer A, I'm going to say h prime of, we wanted pi, right? Is equal to, and just FTC it. I'm just going to take this guy and just chunk it right up in there. So square root, no antiderivative sign, no integral sign or whatever, 1 plus f prime of pi, and then square that guy. And there's no dt business. All of that stuff is gone. And so here, this calculator inactive, so we're just using the table values here. F prime of pi is given to us right about there, which is just 6. And who knows, maybe you do this part in your head. So this is a 6 squared. That's 36 plus 1 is a square root of 37. And as easy as that, that thing is done. So that's obviously 1 point, so plus 1. And does it say show anything? Yeah, show the work, which means that, FTC part is got to be a point. So I'm going to point something out. I know for facts here that here's something that you should not do. First of all, you might want to generalize this and say that f prime of x is equal to the square root of 1 plus f prime of x squared, as in just generally applying the fundamental theorem of calculus, FTC here, FTC 1 or 2, depending on the book you're reading. But what you should not do, this would be a mistake, is say that this is h prime of x, and then in here, just throw your prime. Or here's another thing that sometimes kids do, and I see this all the time on people's papers, like they generally work it out and say that this thing is equal to the square root of 1 plus 6 squared. And this is what the scoring guideline considers a linkage error. Whenever you're saying that this function right here is equal to a function value, which is incorrect. So don't do that. Do not. And the reason why is because chances are you'll get this point here, but you won't get the point for showing your correct work. They'll just take one of those points right away from you. Oh, all right. Even though you're demonstrating that you know what you're talking about, but you wrote it wrong, they're really particular about their notational fluency. Hey, why did I... Wait, what? This is strange. Okay, it's sort of strange. Anyway, so this is sort of exactly like what they asked on A, but now what information does The integral from 0 to pi is square root of 1 plus f prime of x squared provided by the, really? It's almost the same question, and I already answered it right here. It is about arc length, and specifically it's arc length about f, right? I know it's about f because that's the thing that we're taking the derivative of. So this guy, I'm not even going to do a little extra little bit on this one. I'm just going to say that this integral expression represents the arc length, and specifically of f. And notice that they did give us a pi up here where x is. So this means that it's specifically over the interval from 0 to pi. From x equals 0 to x equals pi. Okay. So point value, I think that that's just a point. I mean, just interpreting what this thing is. So I think that's 1, bringing us up to a total of 3 so far. Okay. Euler's method. See what I'm saying? It's like this thing is just kind of all over the place, and they ask the same question twice. Kind of reaching here, I'm thinking. Use Euler's method starting at x is equal to 0 with two steps of equal size to approximate f of 2 pi. Show the computations that lead to your answer. Okay, so Euler's method starts first of all with your with your step size, which is, we usually refer to it as h, but it is the same thing as delta x. And if you're not given what your step size is, it's pretty easy to get because we do the same exact thing on, let's say, a Riemann sum, which is your b minus your a over the number of partitions or the number of steps in your partition. So this is from 0 to 2 pi. So this is 2 pi minus your 0 over, we want two step sizes. So this is 2 pi over 2, which is equal to pi. A very strange step size, but that's what it is. I think we've seen one in one of the problems that we did where our step size was actually negative. At least it's not that. Okay, and now Euler's method, let me just kind of recap and generalize what this thing is all about. In order to get your new x value, so I'll say x sub n, this is equal to your previous x value, and then plus your step size here. So for us, it's going to be plus pi, right? So it's sort of recursive in that nature. And then for your y value, any nth y value is the previous y value plus the step size times the previous slope. So previous slope evaluated, it's the slope evaluated at your previous x values and y values. So f of x sub n minus 1, comma, y sub n minus 1, right? And now the reason why this works is that it's basically, you're just setting yourself up a series of tangent lines. This is going to go from the previous tangent line, evaluate your function at that new tangent line, and then course correct, get a new tangent line, and just keep going. This one's just doing the thing twice. Little bit unconventional. Most of the Euler's method stuff that we've done has been a function, like the slope has been a function of x and y, but ours is just straight up a function of x, and it's given to us in a table. That's a little bit strange, but they do strange things all the time on this AP exam that you guys are about to take. Okay, I like to set this up as a table to organize my thoughts like this. We got some n's, we got some x sub n's, and then we have, well, most of our work is going to be the y sub n's. And our first one, as in before we even iterate this, is our initial position, which was the thing that they gave us in the paragraph, which is 0, 0. Okay, and now I'm going to do one step size. That's going to take the previous x value of 0 and add my step size to it. Obviously, that's going to give us a pi. Now, to get my new y value, I'm going to use my previous y value. Oh, here, let's color coordinate this, shall we? Okay, and then this is going to be this guy, not to be confused with the red 0 up above. No, that's not the same thing. Anyway, so previous y value plus the step size of pi multiplied times the previous Slope. Okay, so I'm going to get the previous slope. So this is basically slope. So f prime at 0, comma 0, like that, right? Anyway, so how am I supposed to get f prime of 0, comma 0? Well, at 0, notice again, it's not dependent upon the y value, it's only dependent upon the x value, which is 5. So actually, I don't need this. It's f of 0, which is, or f prime of 0, which is 5. 5 up in there, and that just gives us 5 pi. Okay, all right, and then let's do it one more time. So here's our second iteration. That's going to take the previous x value of pi. I'll color coordinate this again with red, so this guy matches up with, not that one, oops, 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 this one. And then plus your step size in order to get 2 pi, which is where we want it to be. And this one's going to take our previous y value, which is 5 pi. Again, let's color these. Unfortunately, you don't get to do that on the actual AB exam because you're not allowed to bring highlighters. Plus your step size multiplied times the slope at the previous one. So this is specifically f prime of, what is it, previous, it's only dependent upon x, which is going to be pi. Right, so this previous x value here. Oh, I didn't actually colorize this stuff. Maybe I should have. So this 0 goes with that 0. And actually this pi goes with this pi right there. Yeah, that's how those things are matching up. Anyway, we're going to get f prime of pi from the table. F prime of pi is 6 this time. It's the thing I have highlighted already. So this is a 6, making a 6 pi plus a 5 pi gives us our final answer of 11 pi. So this means that f of 2 pi is approximately equal to 11 pi. Okay, points, I'm thinking that's 1. And since we had to do 2 steps for Euler's method, maybe it's a point for each of them. Depends on, like the last one, like we barely even had, I'm counting 3 points for these, 3, and that's a 6, which leaves us 3 points for the last one. That seems sort of reasonable. Okay, speaking of the last one, let's look at it and see how it's completely disconnected from the whole rest of the question. Find the, well, just antiderivative here, t plus 5 cosine of t over 4 dt, and show the work that leads to your answer. Like what? What does it have to do with anything? This is kind of shoehorned in another BC only topic. It's BC only because this is, if you can't recognize it, integration by parts. How do I know that? I know it because we have ourselves a product inside of the integral, and there's no product rule for integration, but integration by parts did come from the product rule. And also, this is not a traditional like u substitution. I know that because our u would most likely be t over 4, and its derivative is just a 1/4, and that's not what we have. We have something, a function of t up here, all of this indicating that it is integration by parts. Okay, so let's dive into that. For our final part here, we're integrating t plus 5 times, I believe it was cosine of t over 4 dt, double check, k. All right, and then we're thinking limit. And the stuff that we have include a t for our cosine, and that one is closest to the right-hand side, which means this should be our dv. And then we also have a p power, and that's this. Oh, no. Let's change the colors here. Whoops, went back too far. Let's change this one to, I guess, green. And that one is closer to the left, so that one should be our u. Okay, we got this guy set up, saying that u is equal to t plus 5, and du is equal to just dt. So far, so good. And then our dv is equal to cosine of t over 4 dt. And now I'm going to have to integrate this guy. And this is the u substitution part, but I already have a u here. That's kind of confusing. I'll just choose a k. So k is equal to t over 4 is the internal or the composite parts of your composite function. And dk is equal to a fourth dt. And we don't have a fourth in there, so we'll throw 1/4 in there, and we'll have to compensate by multiplying it by 4 on the outside. That means that v is equal to 4 times the antiderivative of cosine, which is sine of t over 4. Right? And then you could always check this by mentally taking the derivative of the v in order to get dv. So I would have 4 times the derivative of sine of stuff, which is the cosine of stuff, times the derivative of the inside part using the chain rule, which would be 1/4, and that 1/4 would cancel out this 4 here, giving us cosine of t over 4, so it checks out. Okay, this means, just rewriting here, integral t plus 5 cosine of t over 4 dt equals uv, it goes straight across here, which is parentheses t plus 5. Excuse me, that 4, I'll just bring that on the outside there. That'll look good. Of sine of t over 4 minus our integral of v du. This is the exchange that happens between the integral that was hard to calculate, exchanging it for one that's easy to integrate. So this one is 4, which I'll just pull this 4 out, sine of t over 4 dt. And then once again, just like the integration that happened here, we'd have to do u substitution, but we know how it plays out. And we'd have to, for example, put a 1/4 in here and compensate with an extra times 4 out here, which is going to make us 16. Keep that in mind. I'll bring this out. So 4 parentheses t plus 5 times the sine t over 4. And the antiderivative of sine is negative cosine, but there's already a negative, which is going to make this plus 16 cosine of t over 4. And don't forget plus c for your constant of integration there. So here's our antiderivative. Antiderivative, of course, is worth a point, so plus 1 there. I'm thinking plus c here, your constant integration is worth a point, and I'm also thinking like your setup for your integration bar parts is worth a point, giving us our 9 total. Let's see how we did and what my guesses were for the points, the 9 points for each one of these. Okay, so on our scoring notes, our scoring guidelines, 2 points on the first one, applying FTC. And our answer, I believe that's exactly what I thought. Our answer was the square root of 37, and the FTC here saying that h prime of x is equal to the square root of 1 plus the derivative squared. Now, I put this secondarily whenever I was explaining something. I actually would not have. I probably would have just had this if I were just working this out and not necessarily had this explanation here. So I'm fairly certain this would still get you that point. So let's take a look at what their scoring notes say. So a response of the square root of 1 plus f prime of pi squared earns the first point. I was correct. A response of just this earns both points. Huh, okay, well look at that. So like it's implied that you applied the fundamental theorem of calculus. Response such as h prime of x is equal to, notice that this is all variable, is equal to the thing that's not a variable, equates a variable expression to a numeric expression, earns at most one of the 2 points. In other words, this is that linkage thing that they discount some, they take some of your points away. Response that equates h prime or h prime of pi to a derivative of a constant such as this earns it's the linkage thing again. So the reason why this one, it doesn't look like this one is wrong, but the reason why this one's wrong is because this is variable stuff, but they don't have the variable up here. They have pi up here. So it's that linkage error again. So we were right with the 2 points. Look at me saying we as if it's like me in my chat. Okay, so they gave us 2 points on this for part B. That's strange. Anyway, they did say that it's arc length, and you get a point for saying that it's arc length of f, and then you get a separate point for the interval. Okay, I thought it was just a single point for the interpretation on this one, which means that one of these points I have to take it away from something else that I did up there. Okay, we'll see what that's all about. So scoring notes, responsive arc length or length earns the first point. Such response does not need to reference f. However, if a response references a different function, the response does not earn the first point. Well, obviously, okay. A response referring to distance explicitly connected to graph of f earns the first point, blah, blah, blah. A response referring to distance that is not explicitly connected to the graph of f does not earn the first point, but is eligible to earn the second point. For example, response of distance, or see, this is too vague, does not earn the first point, but is eligible to earn the second point. To earn the second point, a response must connect the interval 0 to pi to arc length, which we definitely did. Okay. So looking at C, using Euler's method, and this was 2 points. This is the one that I said was 3. So there's just straight up 1 point for Euler's method and 1 point for our answer of 11 pi here. So I broke it up as points for basically pi and 2 pi. They only said that was 1 point. So that was the exchange of points here. They gave this one 2 and then gave this one 2. Let's look at some of the scoring notes. To earn the first point, a response must demonstrate 2 Euler steps using the correct expression for dy dx and at most one error. So in other words, if you make an error in here, just one of them, you still can get this point, but you probably won't get your answer point. And that's what it says, yeah. In order to earn the first point, response that presents a single error in computing the approximation of f of pi must import that answer into the second part of that. That's to get your Euler's method if you made a mistake. And here they're saying that, yeah, you could totally do this with a table, which is the way that I like to organize this thing. And both points are earned for 5 pi plus 6 pi. In other words, just having those two things was enough to get Euler's method and your answer. And you can also say that as an ordered pair. Okay, well, there you go. So since that balances out the points, that does mean that the last one is worth 3 points. Let's see how those 3 points were divvied up. So they divvied them up as u and v. So selecting your u and your dv was worth a point, and your d or uv minus the integral of v du. In other words, actually taking your information from your v and your dv to actually do the integration by parts was another one, and your answer was worth the last one. So I said this was 1 point. I said your answer was actually 2 points, with your constant being your second one. And speaking of that, did we have this correct? I do believe that that is the thing that I wrote. Just here, let's do this for side by side comparison right there, and then just come right up here, and then, wow, really? Okay, paste. Let's see. Compare those, shall we? Looks perfectly right. All right, and let's see what they may have said about this. Okay, so I was a little bit off on this one too, because I said this was worth a point, but the answer included the constant integration as a separate point. The first and second point are earned with an implied u and dv in the presence of that expression. You can do the tabular method, that's the tic-tac-toe method, so you can still get point for that. The third point is earned only for expression mathematically equivalent to one of these guys in the presence of correct supporting work. Here we go. This is important. To earn the third point, a response must have a final answer that includes a constant integration. So in a way, I was kind of right. In other words, they don't even give you this last point if you excluded your constant of integration. If this was, like, all this was right, you would have gotten the first 2 points, but you wouldn't have gotten the answer one without that constant of integration. Is there anything else? Oh, that's McLaurin. That's the last one. I think that's probably about it. A response can earn the first and second by applying integration by part. Oh, this is the alternate solution that they did here. So the alternate solution, they basically distribute this cosine to the t plus 5 like so. So here you don't have to use integration by parts on, but you do have to use integration by parts on this piece. So you'd still have to choose the appropriate u and your dv based on that selection. Okay, so that wraps up this final odd question on this Frankenstein BC only free response question that included arc length, integration by parts, and Euler's method.